Okay, a polynomial is an algebraic expression containing one or more terms, each term consisting of a constant or coefficients and variables with positive integer exponents. So 4x squared plus 2y minus 7 is an example of a polynomial, where terms are the parts of the equation generally separated by plus or minus sign. So each term consisting of a constant or coefficients and variables with positive integer exponents. So constant is a fixed number or doesn't have variables, while 4 and 2 are the coefficients having variables and exponents with them. Okay, now let's take a look at this. So in the polynomials, they are polynomials because all the exponents are positive. And the variables in number 4 are actually raised to 1 because when the variables does not have a visible exponent, its exponent is understood to be 1. Same in number 5, all the variables are raised to 1. To avoid being confused, yes, we have negative 3 and negative 5 coefficients here. But it's okay as long as we have positive integer exponents. How about in the set of non-polynomials? So in number 1, there is negative exponent, while in number 2, polynomials cannot have variables in the denominator. And number 3, polynomials can't have variables inside the square root or radical sign. And last number 4, there's a fraction exponent, because the inverse of this y raised to 1/2 is square root of y. Okay, degree of a term is the sum of the exponent of the variables in the term. So the exponent in number 1 is 8, therefore the degree is 8. And in number 2, the exponent is 10, so the degree is 10. And in number 3, the sum of the exponent 5 and 4 is 9, therefore the degree is 9. Same in number 4, the sum of the exponent is 6, while number 5 we have the exponent 1 and 4, so their sum is 5. Okay, the degree of a polynomial refers to the highest degree among the terms. So number 1, we have 3 terms, right? Let's see which term has the highest degree. We have 3 in the first term, and then 6 degree in the second term, while in the last term is 0. So the term with the highest degree is negative 18x raised to 6. Our goal here is to arrange these polynomials in the standard form. Our leading term is negative 18x raised to 6 followed by negative 3x squared y. It should be descending order when we arrange it to the standard form. So the highest power should be first and the lowest power should be last. So number 2, we have 0 degree in the first term. Second term, we have the degree of 8. And then in the third term, we have the degree of 6. Therefore, the leading term is 12x cubed y raised to 5, followed by the second term, negative y cubed z cubed. And the last one is 6, which is the constant. Okay, number 3, we have the degree of 7. Also 7 in the degree in the second term. And then in the third term, we have 8. But how do we arrange it to standard form if we have the same degree 7? To solve this, okay, let's begin again and determine the exponent of each variable alphabetically. So first is x in the alphabet, right? So the exponent of x variable is 1, while here is 2. And in the last term is 0 because x doesn't exist. Therefore, the leading term is 12x squared y raised to 5. And then 6x y z raised to 5, and then negative y cubed z raised to 5. So classification of polynomials based on the number of terms. So for example, we count the number of terms right here. So 1, 2, 3, and 4. Therefore, this polynomial is quadrinomial. And this one is trinomial. because we have three terms in this polynomial. And then classification of polynomials based on the degree. So, so in the first example, the highest degree is 3. Therefore, this polynomial is cubic. While this one is having a degree of 6. Since there's no available name for exceeding degree, we just name it polynomial degree of 6.
That's it for today's lesson. Thank you for watching.